right? Properly. The video is playing,
Yeah.
or is there any lag?
Nope.
Okay.
Everything is fine.
Okay. Thank you for confirmation. So today I'm going to talk about big data. So I will try to cover everything about the big data from what is big data, what is its use cases, applications, what are the current challenges in big data, and why this is a buzzword. So many things I'm going to cover in this session. In the meantime, whenever you have some questions, please park it, or you can just ping in the chat, so we can cover that at the later moment at the end of the session. So the big data is since it's now mature, but its new child or new baby is data science or AI. Many people are talking about interchangeably data engineers, data scientists, big data. So many people are still have confusions all these things are same or different. So hopefully in this session you will get lots of things what is big data and storing, processing. So this is today's agenda. Why we are using big data tools, applications, big data challenges. At the end, I'm also going to cover some of the architectures where you can see the tools in the real pictures, how they are integrating with each other. So near about in big data, I will say 400 or 500 tools altogether. Some are retired and some are still new and coming on the day-to-day basis. Okay, so what is big data? So big data is a new oil. In recent one of the interview might be remember Mukesh Ambani he said that big data is new oil. So they are transforming Reliance from oil and refinery industries to big data side or some kind of data industries, right? So they had started the Geo with the same concept, and why Facebook, Google, Azure, Microsoft are more interested in this Reliance just because of that Reliance has lots of data outside and inside of the all the kind of rural as well as urban, suburban, metropolitan cities, all kind of data. Like Reliance started its Geo for at very low cost or very cheaper price, and they had acquired lots of data. So that's why the data is a new oil. Everyone is interested in data only. And in the later on, you will also get understanding that why data is a new oil and why this is much has higher priority one than the oil. So you can consider that as a big data is the new aviation fuel in the future. Okay, so some following slide, I'm going to give you different definitions of big data, but don't get bored. So first, big data is this is like for Foresters has said big data is a frontier of firms' ability to store, process, and access all the data it needs to operate effectively, make decisions, reduce risk, and serve customers. Okay, next. Oh, it's boring. Let's move ahead. Okay, this is by Gartner. So big data is generally defined as a high volume, velocity, variety information, asset that depend cost, effective innovations, forms. Okay, let's move ahead. It's Nori. Wake up, guys. It's morning. Okay, so next is big data is a data that exceeds the processing capacity of conventional database system. The data is too big, move too fast. Okay, let's move on. Too many words. IBM said big data is a data characterized by attributes like volume, variety, velocity. Again, some random words, I don't mind. Okay, next, big data is the data characterized by four keywords. Okay, Oracle has added one more keyword like value. So volume, variety, velocity, value. Okay, buzzwords again. Oh, it's too much words. So let me make it very clear in some simple terms. Uh, okay, so let's look at big data in a different way. I hope you guys enjoying the way of presentations. What was your first computer? Okay, let's start from that. Yeah, anyone have question? Okay, so this one might be if you are a child from 1980 or 1990, this one was your first computer, like such keyboard. Previous company's keyboard was look similar, where the tone of specifically while you are typing tuck tuck tuck, it was very irritating. But anyhow, it was your first computer. Okay, what was its big data limit? So in 2013, this Deus Borat has tweeted one thing small data is when it fits in RAM and big data is when is crash because it's not fit in RAM. So this is again some kind of nowadays it is a kind of, we can say that it is some kind of funny definition of big data. Okay, let's try again. Still, I know you guys didn't get clear like what is big data. Okay, let me go some different example. Am I making sense, guys, or I'm going too fast? Please, anyone confirm?
Noted.
Okay. Okay.
It's good.
Okay.
Yeah, Rajat.
Okay. Yep. So like if we talk about bytes, so you can consider that bytes is 1 grain of rice. Okay, kilobytes. So 1 cup of rice. Megabytes. So let's consider megabyte as 8 bags of rice. Gigabytes. So 3 semi trucks. So you consider that some 3 semi trucks of rice is gigabytes. Terabytes. So 2 container ships. You can consider this many data as terabytes. Petabytes. So blankets of man density. So like you can try to consider it like the data which covers this man density. It's petabytes range. Exabytes. So there are near to 8 or 9 states that is going to be covered in that. If this is just a simple comparison, like with the data and with some regional or area. So exabytes is like West Coast states. Jetabyte, like you are trying to fill the specific ocean with the data. So that much of data is can we can consider it as a jetabytes. Okay, so why this many things? So I'm just trying to compare like a big data. That doesn't mean that you have exabyte or petabytes of data. That means only the it's a big data. So big data, you cannot measure something like if something is this many centimeter of this many kg or this many device it needs to be stored. So that is a big data. Otherwise, it is small data. Okay, let's me move ahead again. Okay, yottabytes. So Earth-size rice bowl. So can you consider that like one rice is of size of Earth? So it is a yottabyte. Okay, so now let's classify these things with computer terminologies. So bytes and kilobytes. So obviously, our 1980s or 1990s keyboards and whatever the machine was that on that time that was capable for storing bytes and kilobytes data only. Then megabytes and gigabytes. So like desktop, even on that times desktop was able to handle like up to some. I remember like 256 GB RAM hard disk was that maximum that time. Then terabytes or petabytes. So currently, like what are the internet we are accessing on daily basis. So that is capable of handling this many types of this many bytes of data like terabytes or petabytes exabytes and zettabytes. So this is something different where the big data is coming into the pictures, right? So when you have like exabyte and zettabytes data, you cannot do that kind of processing over your desktop or your internet or what are the right now the devices or tools right now exist. And yottabyte, okay, again this. So like right now the Facebook, Yahoo, Amazon, eBay, Google. So all these organizations had this much data, and that's why they are required this big data stacks just because of that processing this many things and in real time in some batch processing. So it is more important to that like whenever some data is coming to you at the fraction of second it has a higher value rather than the data which is already present in 2 years back. So let me give you example like let's say I'm searching something on amazon.com and let's say I'm searching for shoes and in the next moment like if I'm moving from that amazon.com to some another website it is giving me shoes advertisement, right? Just because of that at that time that data is more important. If you come again like after 1 or 2 months and if you are again going to some another website you will not get that shoes just because of that the data is now has a lesser value. So the data as much as fresh has a higher value rather than the data is going to be older. So that's why like Facebook, Yahoo, Amazon, all these organizations are more interested in this big data and they are want to trying to process as much as they can on every fraction of second that it could be like streaming. Yottabytes, so it's a future, still it did not come in the picture. Okay, so this is the real thing, the 5 V's of big data. Okay, I'm holding here. Anyone any question? regarding the slides I covered before. Okay, so move ahead. So 5 V's of big data. So volume, variety, velocity, value, and veracity. So let's go one by one. So scale of the data, volume. So this is some older slide. I guess this is like 2011 or 2015 slide, but you can just compare it with the current state. So like on that time, 6 billion people has a smartphone. So now you can consider that 11 or 12 billions will have a smartphone. So this many volumes of data, like 40 zettabytes or 100 terabytes of data stored. Most companies in the US, at least 100 terabytes of data stored. So you can consider that this data storing capabilities is also going to be increased in year by year. Then velocity. So if we talk about the velocity, so velocity means like how fastly data is transferring from one system to another. From like let's talk about some IoT enabled cars or autonomous vehicles. So autonomous vehicles has a thousand of sensors, temperature sensor, water sensors, some hurdle sensors, cameras. So many things are there, right? And they are processing all these things at very real time. They cannot give like let's say the car is going on the way and it is not going to be give you like after half an hour once it met the accident that yeah this was the problem. So everything processing is doing at a very fraction of a second. So you can consider that a velocity like some IoT devices, census data that are generating lots of data and they are transferring those data to some server via any PubSub mechanism or any like Kafka streamings or anything you can consider. And that is the velocity. Like data is moving faster from one device to another, from uh, uh, some databases to another databases for processing. Variety. So variety, you can consider that now. So in the last, I will say that 10 or 15 years ago, data was only formed in the relational databases, right? So like some table structures data were only there, or some XMS data was there. But nowadays there are lots of data formats. Like YouTube have some kind of another data format, JSON, XML, CSV, uh, videos, YouTube videos, then tweets, comments, likes. So there are different forms of data, some text data. Like every system is not generating the same kind of data. Some systems are generating text, some systems are generating JSON data or some scripting. So many things are there. So we can consider that as a variety of data. And you have to handle all this variety of data. Like so, like if you have one system, so you should be able to handle either it's coming from YouTube, it's coming from Facebook, it's coming from Twitter. So that is a variety. Now the value. So anyhow, why people are collecting this data just because of that it's creating some value. So having access to big data is all well and good, but it's only useful when it can turn it out to into value. So like only storing the data is not going to be give you some value, right? So out of this you have to extract some insights, and that is your real output that you can consider it as a value. Then veracity. So veracity means that what are the data you are collecting, gathering, you are storing. That doesn't mean that it is like 100% sure or trusted data. And that is the main issue. Like in the US, 3.1 trillion a year lost due to the poor data quality. So whenever you are gathering data, ingesting data, you should also be ensured that what are the data you are gathering, it should be some authenticated data. It should not be like some junk data. I guess am I making sense here? Okay, so storing big data. So now I'm going like so this, up to this it was like what is big data, and I tried to explain you all the things in a very good manner, like scaling, uncertainty of the data, and all these things. Now we are going to like storing and processing of the big data. So storing means analyzing your data characteristics. So whenever you are going to ingest some data, so first you have to identify like what is your data. It is going to be relational or NoSQL kind of data. It's a key value pair, graph, documents. So nowadays, like yeah, even many systems are storing the data in graph. Some systems are storing the data in Parquet, like Spark. So there are different kind of things. Like every data format has some kind of advantage and disadvantage. So let's go to the here, analyzing your data characteristics. So selecting a data source for analysis. So like let's say you want to do some analysis. So first you have to select and identify the proper data set. Until and unless it is not a proper data set, you could not get some fruitful insights from that. Eliminating redundant data, like let's say you have some data but you are not eliminating redundant data, then again it is going to be create some kind of bias in your data itself. Establishing the role of NoSQL, like if it is coming some unstructured data, you can store it into the NoSQL. So you have to first identify like in which system it is going to be stored. Then big data stores or key value pair, graph document data, column family like columnar is a part. Hadoop distributed file system, so HDFS. So HDFS is like again comparing the HDFS with like legacy storing system. So there are a large difference between that. HBase and Hive. So Hive is again like storing for NoSQL kind of data structure, but it doesn't support the SC property, but it has some kind of capability that on other relational databases cannot give you. Okay, processing a big data. So first, this slide was storing a big data, and this is a processing a big data. Like now, let's say you have stored the data, but now you have to process the data for finding out some analytics, for transforming, right? So integrating a disparate data stores. So like let's say you stored your data in like one is relational database, some is non-SQL databases. So you have to integrate all this data. You have to ingest all this data from different sources. Then it's come to transformation steps or load step, like either you are doing ETL or ELT. So in that case, what you will do, you will define some transformation steps, like you want to remove some redundant data, you want to uh, do some kind of aggregations over that. So it's going to be like when the data is ingestion phase is started, once the data is ingestion, it is going to be transform something, like whatever your requirement. According to that, you can write some logic in the Spark job. So like you can write some different Spark job, and that jobs is going to be perform on this big data, and it is going to be give you some output. So like output means that you are loading the data into some system. So let's say some junk data was there. I am transforming those data, writing some script over there, and I'm loading the data again into some another system. So this is called ETL. Now employing the Spark framework. So when you are considering this kind of framework, so in the legacy people were using Hadoop and MapReduce, but it has some kind of drawbacks. So now people are mostly using Spark framework. It is 100x faster than the Hadoop. So creating the component Spark job. So like whenever you are planning to do some kind of Spark job, you have to first identify that what the things you want to perform, and how the data is going to be partitions. So you can get easily, like let's say simple terms. Let's say you are storing Amazon data, then you might be want that the data should be, you want some kind of statistics on every month. So you can partition your data based on that month column. So such kind of things you have to identify. Then executing a Spark job and monitoring the process of job flow via orchestration tools. So like Airflow. So what is Airflow? So Airflow is not like a thing which is going to be executing or processing, but it is just keep some monitoring. Like let's say you have a single system, you can monitor yourself like single job. But let's say at the same time you have thousands of jobs, all jobs is running at every 5 minutes, or some jobs are running at every 12 IST. It is very hard to maintain all these things and maintain like what is the state of the jobs, why some jobs are failing. So in that case, some orchestration tool like Airflow, it is going to be useful. Okay, so again, why big data? Uh, so the thing is that like why people are more attracting to the big data. So these are the some statistics. Even the statistics is 2019, 2 years back. So you can see that like hash love, it was posted 23,000 times. Twitch is Tumblr. So many like social media sites, Airbnb, Uber, Tinder, Google. So this many searches per day, or you can consider that this is all going to be very large scale just because of its 2019 data. So this many data are generated per day from a single system, from a single organization. You can consider the Netflix or Jiffy or YouTube. So these many data are any organization collecting this data at continuously. They are not going to be like turn on like once the data is collected for 1 month. They are going to be shut down their system. So it is continuously collecting some data. They are identifying some fruitful result out of them, and the end, if the data is older like 2 3 years, then this data is going to be in the archive folder, but it's not going to be retired or it's not going to be paused anyhow. Okay, so some tools and technologies. Okay, so Hadoop, Spark, Kafka, Cassandra, Hive, MongoDB. So these are some basic tools which people are using on day-to-day basis for big data processing. Okay, so use cases and applications. So use cases wise, I listed only these 5 use cases, but you can consider it as any use case. Let's say government. So government wants some fraud detections, some scientific research, some improving services, such kind of things. Then government continuously storing that data. They will identify, they will predict something based on that. Manufacturing, like output forecasting, some census data is there, then they want to defect some tracking. They want to predict that that sensor is going to be fail in some times or not. So before that machine is going to be shut down, they can replace that sensors. Healthcare. So again, like even the Indian government is now trying to come into these pictures, like they continuously improving their services and they want to make everything in the digitalization platform. So like if you just consider that the day before government of India has released like health card for each and every citizens of the India. So you can consider that how many bytes of data or kilowatts of data is going to be stored when this it is going to be implemented throughout the India. So it is again going to be they can do some kind of analytics on that and identifying that like this is the chance of this people is going to be such kind of disease in the future, right? Media and entertainment. So like nowadays so like if you talk about legacy like 2 or 5 years back, when there was not like that many of platforms for ott platform like Netflix, Amazon Prime, but nowadays like lots of platforms are there. So handling this such kind of data, like which person is watching what kind of seasons or episode, what's their likes, what's their emotions on that comment. So analyzing this and based on that predicting something like yeah, that particular person will like such kind of movies or such kind of series. So that is again one use case. Is then IoT. So improving the customer experiences. So like IoT mostly, if you can say that autonomous cars. So like such kind of devices, they are going to generate lots of data, and based on that, they will try to improve itself. Here are some roles like big data architect, big data engineer. So they have very minor things in between that, but you can consider that all are like big data engineer, data engineer is a new terms. So it is not like that. Yeah, like government is only government use case is only handled by this big data architect. So it's like a very small differences over there, but you can consider that everyone is a big data engineers or big data developer. Okay, architecture. So I'm going. I take some random architectures just for give you some more understanding, like in the technical depth. So let's consider that some Twitter's data, some web data, some email data, some notes data are coming. These are your data sources. So your first layer will be ingestion layer. So this is some third-party data. Or you can consider that the data sources, either it's a web API or from any sources. So this is your data ingestion layer. So first step is ingesting the data into your databases. Okay, so your data storage layer could be either S3, HDFS, Gluster, file systems, or anything. I'm not stick to any particular storage. You can store your data at any places, whatever the data places you like. Okay, so like HDFS, S3, also Azure is providing some kind of data factories. Now, once your data is stored, so this is your first step, this is your second step, like the data is storage. Now, once your data is stored, you are going to process it, right? So either it's a batch processing, real-time processing, or hybrid processing. Some said it's a micro processing as well, or micro batches as well. So let's consider batch processing. So batch processing means that you are processing the data at some particular time only. Like let's say 20 once in a 24 hours. So your job will be start at midnight, and it is going to be process all this data, whatever the data is collected throughout last 24 hours. Real time processing means that like use cases of Uber, right? So like if you are just requesting some Uber car, that at the same time it is trying to do some processing with weather, with traffic, so many things it's coming into the that particular place. And based on that, it is identifying that let's say trying to move from X location to Y location. So it will identify that how many hurdles are there, how many traffics are there, what is the atmosphere of that particular area through where this driver is going to be drive the car. So based on that, it will predict you price. So same case of the Zomato, right? So if you are ordering some food from the Zomato, so it is again going to be checked like today is a Friday and time is at 9 p.m. So it will check last Friday or last couple of Friday 9 p.m. time. What was the rush over that particular restaurant? How many orders were pending over that restaurant? Based on that, it will identify that this is a time where you will get your food delivery. So this is you can consider as a real-time processing, some hybrid processings like they are mix and match of both this. Okay, so this is your second, third layer. Now the query. So like once this processing is done, so based on that, you can also do some kind of real-time processing queries. Like Kinesis is providing some real-time processing queries, Spark SQL. So like at the time of doing such kind of processing, you can use Spark SQL. So it is like same as SQL query. You can just directly write into Hive. So whatever your data is on HDFS, you can directly query over that. Presto, then Amazon Redshift. Amazon Redshift is again a data warehouse tool. Now like once the data is stored, like you can querying something, you can processing something, and again you can store into some like Amazon Redshift or Snowflake or Azure Data Factory. So that is your ultimately like a factory or data warehouse where you are in the future you are going to utilize that things for another analytics kind of stuff. So in the previous slide I explained like ETL. So this is extraction, so this is E, and this is data processing. So this is a loading or transformation steps, and this is a loading step. So this is E, and this is T, and this is L. In some cases, some people start doing different way. Like first they are doing ELT, so extract, load, and then transform. So this is ETL steps. Now, once your data is transformed and loaded into some Snowflake or Redshift data warehouse, now you can do some kind of analytics over that. You can create some machine learning model and try to predict customers' behavior, some predictions over there, like what will be the sales forecast or such kind of things. And like once the data is analyzed and once that model is created, the similar time you can do some kind of visualization over the using some Tableau or real-time dashboard or Looker. So many tools are available, Power BI. So that is going to be in the data analytics person's job. So based on that, they can identify that this might be the reason or what was the sales in the last month. So many analysis they can do based on this. Okay, this is some another random use cases. So like similar to that, mobile apps, websites, microservices, IoT device. So all these your data sources, it is going to be ingest via some third-party services or query or REST API input it or messaging queue. So, like let's say this is your HDFS and it's some messaging queues are there. You are going to store all this data in the data lake. So, data lake is what? So, data lake is just you can consider that as S3. S3 is also you can say the data lake. So, where your all the data is going to be resides. All your data is like you can say that one single source of truth of all your data. So, that is a data lake. So, like all the data is coming from these ingestions where you are doing some processing over that, you are storing that into the data lake. And again you can once like some another process you want, you can again take data from this data lake and do some transformations or any kind of operations, again store the data into data warehouse. And data warehouse is like the place where this business use cases or machine learning team utilize those data and generate some models based on that. So you can see here this business analytics tools, either it's a Looker or a Snowflake, Quick, or any kind of business analytics tools that is used for presentation layer. This layer is you can consider as a preparations and computational layer. This is an ingestion layer. Okay, so what is the current challenges in this big data? So you can consider this is has a lots of information. So here first you can check that complexity, velocity, variety, and volume. So all these things are based on some kind of categories, like if it's archive databases, right? So in that cases, velocity will be low. Archive means that data is already residing in some places and it is not going to be utilized very frequently. If it is a documents, then in the case of documents, the variety will be high, velocity will be low. In the business apps, again, the velocity will be high, variety will be medium, but the volume will be high. So you can compare all this. In the case of sensor data, so volume, variety, velocity, everything will be high. Okay, so archive docs, business applications, all these kind of data based on their category, like social network data. So social networks like Twitter, Facebook, all these things. So you can consider the velocity will be high just because of that. On social media, and each and every second, people are doing likes, comments, views, so many things, right? So based on that, its velocity will be high. Okay, big data analytics. So this is some analytics. It's from 100-foot view. So first, let's talk about the data discovery. So value performance. So data analytics or data scientist team will identify some data discovery, some value out of this data. Business reporting. So they will check data quality and they will do some kind of presentation layer from the data. Real-time processing. So like consumers or intelligent agents, you can consider the real-time processing data use cases of the Uber or Zomato. So whenever you are doing some kind of orders, they will try to do real-time processing and finding out some real-time intelligent out of them. Okay, so now traditional analytics versus big data analytics. So traditional analytics means you can consider that the 5-10 years back, like what people were doing is that they will storing them data. Then based on that, they will identify why this happened, why this not happened, why this sales is low. Such kind of things was traditional analytics. But now in the big data analytics, you can focus on predictive analytics or data science. Predictive analytics based on that, like you can identify that this person is going to be purchase such kind of series or not. So that is a predictive analytics. Data sets. So in traditional analytics system, the data was cleansed data and simple models were there and limited data were there. But now you have large scale data, more rows, complex data models, different type of data formats, correlations, so new insights and more accurate answers, right? So in the big data analytics, you will have some kind of different insights rather than that traditional one. Just because of the traditional one, people were just identifying that why this happened. But now in the big data analytics, people can identify what could be happen. Okay, expectations from big data. Okay, so why people are so many curious about the big data and why organizations are so many investing in this big data. So what is the expectation from the big data? So decrease in operational cost. So organization wants decreasing in operational cost on day-to-day basis. Data-driven cultures. So this is a new buzzword. So in the LinkedIn or in some of the news, you might be heard that companies are trying to go data-driven cultures, new avenue for the new innovation and disruptions. Obviously, like if you have some kind of data, you can do some kind of new innovations, and you can take advantage of that for increase your revenue. So there's so many advantages are there that organizations are expecting from the big data, launch a new products and services. So in very simple terms, like if you have some customers data, then based on that you can identify that which customers is spending how much in each month, and based on that you can targeting those customers. Let's say Amazon want to launch a new mobile, then what it will do that it will targeting only those peoples which are focusing or which are purchasing the like iPhone or such higher range products. So they will only targeting those peoples. Monetize the big data through increased revenue, transform business for futures. So any business which is not going to be adapt the big data or such kind of data tools, they are not going to be in the more future business. Okay, thank you all. Any questions?